Welcome, fourth graders. Hopefully this video finds you doing well and enjoying your evening. Our focus this week is the multiplication strategy, breaking factors into smaller factors. What's nice about this strategy is it will be used a lot. I mean, it can be used a lot if it's something you become efficient with. Doubling and halving, we talked about doubling and halving last week where we said, well, if you're multiplying something by 25, doubling and halving is great because you can just, 25, double 25 is 50, double 50 is 100, and multiplying by 100 is easy. Remember how we also talked about, well, if there was an 8 in the number, or a 16 or 32, because then you could, what's half of 8? 4, half of 4, 2, half of 1. Well, that's so doubling and halving, it's a strategy, but it's a strategy that really works well if you understand that it works best with certain numbers. Breaking factors into smaller factors is not in isolation. It works with multiple different numbers, and so in that sense it's going to be nice. Also this week on your learning opportunity, you have 4 challenge yourself to go above and beyond. Please, please, please make an honest effort to solve them. And those problems are designed to make you think critically, not just mom and dad. I think it's great if mom and dad want to guide you through the process, but it's really about you working with them. And if you get stuck. It's okay. But I want you to think critically, and I want you willing to learn from your mistakes because you actually took some time to try to solve them. Okay? It's always be willing. Hey, ask your peers. Come into school and say, hey man, I tried that problem B and wow, that was really cool, but I'm still a little confused. How did you go about solving it, or what were you thinking? Really be willing to think about the process. Okay, so let's get started with our strategy this week. So if we looked at 16 groups of 15 or 15 groups of 16, well, we know that 16 is the same as 2 times 8. We also know that 15 is the same as 3 times 5. So we have 2 5s, which is 10. We have 3 8s, which is 24. And we know 24 10s is 240. Another way we could have broken that up is maybe we don't look at 2 times 8 is 16. Maybe we look at 4 times 4 is 16. So 4 times 4 times 3 times 5. Well, in that situation, I could have said 5 times 4 was 20. 4 times 3 is 12. So if I have 20 groups of 12, well, that's also 240. Because think about it, that 2 is telling me to double the 12, so that's 24, and then the 0, right? Because I don't just have the number 2, I have 2 tenths, right? So if 2 times 12 is 24, and then 24 tenths is 240. Now, look at 35 times 24. Well, we know 35 could be 5 times 7. We also know 24, maybe it's 4 times 6. Well, 5 4s is 20. 7 6s is 42. So if we say 20 42s, well, 42 doubled is 84. But remember, that's not just a 2, that's 2 tens. So that would be 840. Maybe you say, well, I really like working with tens. I agree, I like working with tens also. So you could say 5 times 7 times 2 times 12. So 5 times 2 is 10. 7 times 12, 7 tens is 70. 7 twos is 14, so that would be 84. So 10 84s, well then, that's also 840. Now, obviously in the first 2 problems, we had the luxury of being able to find a friendly 10 because of the 5 being in both numbers. We don't have that luxury in our third problem. So we have 32 times 48. This really is one that kind of guides you into truly breaking into smaller factors. Or just saying, hey, I wouldn't use this strategy, I'd use partial products, or maybe I'd use an algorithm, I'd use a different strategy. So if we think about this, we know 32, sorry about that, I just made an error, I meant to make that a 2. We know 32 is the same as 2 times 16. We know 48 is the same as 6 times 8. Well, I don't know if there's anything that really works coming together, so let's keep that 2, but let's recognize that 16 is also 2 times what? 8. And we also know that 6 is 2 times 3. And then we also know, well, let's actually, let's keep that 8. And let's see if this doesn't help us. Because then we could say, well, we know 8 times 8 is, right? So 8 times 8 is 64. And then, if we think about this, we could say 64 times 3, because I know 60 times 3 is 180. 4 times 3 is 12. So 64 times 3 would be 192. And then with 192, we have to, right, double it 3 times. So let's see what happens. So 192 plus 192, that gives us a total of, well, we have 100 plus 100 is 200. Sorry about that. I don't know why it moved on me. 100 plus 100 is 200. 90 plus 90 is 180. 2 plus 2 is 4. So that would be 384. Then we have to double that again. So 384 would be 300 plus 80 plus 4. 300 plus 80 plus 4. Sorry about that, I'm using my old stylus. So that would be 600. 80 plus 80 is 160. And then 4 plus 4 is 8. So that would give us 768. But remember, we still have one more 2 to work with. We're not done. So we're going to have 700 plus 60 plus 8. 700 plus 60 plus 8. So that's going to be 1400 plus 120 plus 16. Let me get that 16 written better. Sorry. So we had all that together. We have 1,536. So again, breaking factors and smaller factors can be used for this problem. Again, you might have fall back to partial products for this problem, or doubling and halving, because the 32 would become 16. 16 would become 8, 8 would become 4. But if you think about it, we kind of doubled and halved it how we did it this way. But that's 1,536. So hopefully this gave you a little bit of guidance with your learning up. And if you have any questions, please ask, and enjoy your week. Thank you.